How do VAs detect anomalies using reconstruction error? Imagine a system that learns what normal looks like and then spots anything that doesn't quite fit. That's what variational autoencoders do in the world of artificial intelligence. These models are a type of deep learning that can generate new data and understand patterns. They work by compressing data into a smaller, simpler form called a latent space, then reconstructing the original data from that. When trained on normal data, VAs become really good at recreating similar inputs. The key to anomaly detection is how well the VAE can reconstruct data. It tries to minimize the difference between what it receives as input and what it produces as output. This difference is called the reconstruction error. If the data is normal, the model has learned its features well, so the reconstruction error is usually very low. But if the data is unusual or different from what the model has seen before, the VAE struggles to recreate it accurately. This results in a higher reconstruction error. You can measure this error using simple metrics like mean squared error or negative log likelihood. These give a number that tells us how different the original data is from its reconstructed version. If the number is high, it suggests the data might be an anomaly. For example, in images, if the model was trained on clear, normal pictures and then sees a blurry or damaged image, it won't be able to recreate it well. The difference between the original and reconstructed image will be large, flagging it as a potential anomaly. This process works because VAs learn a probabilistic model of what normal data looks like. They understand the typical patterns and features, so when new data fits within this learned distribution, the reconstruction error stays low. When it doesn't, the error spikes. This makes VAs useful in many fields like fraud detection, where unusual transactions can be flagged, or in medical imaging to spot abnormal scans. In the context of generative AI and deep learning, this approach helps keep systems reliable and safe. It's like having a guard that knows what normal looks like and raises a red flag when something strange appears. The higher the reconstruction error, the more likely the data is an outlier. That's how variational autoencoders use reconstruction error to find anomalies efficiently and effectively.